Hello and welcome back to TensorFlow. Today we are diving into one of the most fundamental topics in natural language processing, which is text representation techniques. So the question is, have you ever wondered how machine understand human language? Well, they don't actually read like us. Instead, they convert text into vectors, text into numbers, or more specifically, they convert text into vectors. So in this video, we'll break down the text representation starting from the most basic techniques like one-hot encoding, the most advanced one like word embeddings. So now let's discuss what are the goal of text representation. Why are we doing this? So as we know, machine don't understand human language. They don't understand the textual data like this. But if you will give them numbers 1, 2, 3, 4, and so on, they will understand these numbers. So we have to find a way to convert text into numbers. But the condition here is we have to capture the semantic meaning, the semantic of that text, the context in which that text is getting used, the context, and we have to maintain the sequence of text, because in textual data sequence matter like this. If you have let's say my name is John, so in this sentence if you will replace name with John, so it will become my is name. So it will change the meaning of sentence, and this sentence is incorrect. So we have to maintain the sequence of sentence as well. We have to capture the semantics and the context of the text. So these are the goal of text representation. Now let's start with the most basic text representation technique like one-hot encoding. So one-hot encoding is the first and the basic technique of representing text in the form of numbers or vectors. So before diving into this one-hot encoding technique, let's first understand that what are vectors. So vectors are nothing but they are array of numbers like 1, 2, 3, 4, and so on. So this is a vector. But in natural language processing, we take the length of the vector, we take the length of this array as a dimension. We say that if we have a vector like 1, 2, so we will say this is a 2D, two-dimensional vector, or the vector representation of text. And we can also represent this in the 2D plane. So we can plot this point here, and let's say this is the textual representation of word hello, and we have another word, and the textual representation is 2, 6, let's say, and we can plot this point here. So we can plot these vectors in the 2D graph to see that if they are connected to each other or not. So this is the use of vector, and this is what vectors mean. Now let's see that what is one-hot encoding and how it works. We will see the mathematical intuition behind one-hot encoding, and we will also code Python and implement this one-hot encoding technique. So let's get started with the mathematical intuition, that how one-hot encoding works and how we represent text in the form of vectors using one-hot encoding. So for example, let's say we have one sentence that the dog is, and we have another sentence, the dog is bad. Let's say we have these two sentences. Now we have to represent these sentences in the form of vectors, and we have to use one-hot encoding technique. So what one-hot encoding technique does is it will count the number of unique word in the document. What document means is in whole data. So the number of unique words in the data are 1, 2, 3, 4, and 5. We have 5 unique words in this document. So we will write these 5 unique words in a row. The dog is good, bad. So after that, we will represent every word with n-dimensional vector. So this n in one-hot encoding, this n is equal to the vocabulary. Vocabulary means number of unique words in the sentence. So let's say we have 1, 2, 3, 4, 5, 5 unique words. So we can represent every word with 5-dimensional vector, which means this is the condition of one-hot encoding, that we have to represent every word with 5-dimensional vector because we have 5 unique words in the document. So let's see how we can represent it. So for let's say we have to represent the in the form of numbers. So for the, we will write 1 in the place of the, and in place of every other element we will write 0. So this is the vector representation of word the. Now let's see for dog. The vector representation of dog is 0, and we will write 1 in place of dog, and at every other place we will write 0. So this is the vector representation of dog. Now let's say for is, it will be 1 0, 0, 1 0 0. Same for good. So good will become like this. At every place we'll put 0, and in place of good we will write 1. So in place of 1 we will write in place of bad we will write 1. So these are the vector representation of the dog is good and bad. Now we can feed these numbers to our neural network or to our model, and it will train and predict the next word, or it can generate text and every other NLP task that we want to do with this text. So this is how we represent words in the form of vectors in one-hot encoding technique. So now let's see how to code this and implement this in Python. So in Python, we have inbuilt library of one-hot encoder in sklearn. So we will import one-hot encoder. So from sklearn, we will import from sklearn or processing, we will import from sklearn dot pre-processing, we will import one-hot encoder. Import numpy for converting data into numpy array. So we will import numpy as np. Now let's create our data. So our data is np dot array. We will convert our words in the form of array, and now we will pass our words here. So let's say the first word is cat, and the second word is dog, and the third word is water. So the vector representation of these three words. So we have three unique words in the sentence: cat, dog. We have three unique sentence in our data: cat, dog, and water. So we will count the number of unique words. So number of unique words are 3. So every word will be represented with 3-dimensional vector here. In one-hot encoding, the number of dimension depend on the number of unique words in the data. So we have three unique words in data. So we will represent every word with 3-dimensional vector. So the vector of cat will become 1, 0, 0. The vector of dog will become 0, 1. The vector of water will become 0, 0, 1. So these are the vector representation of cat, dog, and water. Now let's see in Python how to do this. So we have created our data. Now let's create the class, the object of this one-hot encoder class. So to create the class, we will name it as encoder class. So we will write encoder, and we will. So here we want sparse representation. So sorry, we don't want sparse representation. So we will write sparse equal to false. Now we have one function in this encoder class. In this one-hot encoder class, we have a function called fit transform, and we will pass our data in that function, and it will generate the encodings of one-hot encoding of every word. So we will write enc dot fit transform. We have a function fit dot transform, and we will pass our data here. So we will pass our data here. Sorry, enc.fit transform, and we will store these encodings, encoded one-hot encoding in the variable m. So now we have stored all the one-hot encoded vectors in this m variable. So this is the function called fit transform, and we just have to pass our data, and it will automatically generate one-hot encoded vector for all these words. So now let's see what. So these are the vector representation of the word. So if you will see, for the first word, this is 1, 0, 0. So this is for cat. So for cat we have 1, 0, 0. For dog we have 0, 1, 0, and for water, for dog we have 0, 1, 0, and for water we have 0, 0, 1. Now let's discuss the advantages and disadvantages of this one-hot encoding. So the advantages, obviously, we are representing text in the form of numbers or vectors. The advantage, because now our machine can understand that what we are trying to say and what is this text representing. Now let's discuss the disadvantages. So the disadvantages, let's assume we have a data of 10 lakh rows. We have data with 10,000 unique words. So 10,000 unique words in our data. Now for every word in that sentence, we have to represent it with 10,000 dimensional vector. So this will take huge memory. So this will take much space in our system. So, and it will take it will be very costly for us, and also it will require huge computational power to compute to calculate all these vectors. And one more disadvantage is, if you will see, let's say we have 10,000 unique words in the sentence. So the representation of first word will become 1 and 0, 0 and 9,999 zeros in sequence. So these zeros are not representing anything, but they are still taking space in our memory, and our computational cost will increase. And this is sparse representation, because this is representing in the form of zeros. There are too many zeros which are not taking part in calculation also. They are just taking memory and increasing the computational cost. So these are the disadvantages of one-hot encoding vectors. Now let's move forward for advanced technique like TF-IDF. So TF-IDF, term frequency inverse document frequency. The full form of this is term frequency and inverse document frequency. Is the one of the most widely used text representation. It assigns importance to words based on how frequently they appear in a document, while reducing the weight of commonly occurring words. This helps identify significant term in text. Let's see how to. Let's take a mathematical intuition behind this. So this is the formula of TF-IDF. This is the formula of TF-IDF. So now let's break this down and understand that what this is representing. So we have two terms here: term frequency, which is TF, and IDF, which is inverse document frequency. So let's first discuss term frequency. So what term frequency means? The term frequency means number of times the word is occurring in a sentence. Word is occurring. Number of times the word is occurring in a sentence. Let's say we have a sentence that is, but yellow cat. Let's say we have this sentence. So the term frequency of cat in this sentence is 2, but the formula for term frequency is TF is number of time number of time the word is occurring in the sentence upon total number of words in the sentence. So this is the formula. So the term frequency for cat in this sentence will be 2 by number of words in this sentence. So 1, 2, 3, 4, 5, 6, 7, 8. We have 8 words. So the term frequency of cat in this sentence is 1 by 4. This is what term frequency means. Now let's see what IDF means. IDF, inverse document frequency. So inverse document frequency, the formula of inverse document frequency is this: n upon dfx. N upon dfx. So this is the formula, log e n upon dfx. So let's break this down and understand what this inverse document frequency means and what this formula is representing. So here the n is representing, n is equal to total number of words in the document. Total number of words in the document. So let's say we have 5 sentences. So we have to calculate total number of words in these 5 sentences, and will become our n. Now, what this dfx is representing? So dfx is representing number of document containing x. So we have 4 sentences. First is hello world. Second is world is beautiful. The third is world is fine. And fourth is my world. These are the 4 sentences in our document or data. So the n here is 1, 2, 3, 4. So we have total number of document are 4. So we have n equal to 4. Now let's see what this dfx is representing. So dfx means, let's say we are calculating IDF for this word world. So for world, this dfx will how many sentences this word is appearing, which means in this sentence world is here. Yes. So in this sentence world is here, in this sentence world is here, in this sentence world is here. So 4 times this word is occurring in every sentence, which means IDF inverse document frequency is equal to log e n upon dfx. Now let's take an example and see that how to calculate IDF for a given word. So let's say we are calculating IDF for this hello. So IDF for hello will be equal to log e total number of n equal to total number of document in the data. So total number of sentences in the data are 1, 2, 3, 4. So total number of sentences are 4. Now how many times, in how many sentences this hello word is occurring, in how many sentences this hello word is occurring. Df means in how many sentences this hello word is occurring. So now let's see in how many sentences. So we have hello in this first sentence, we don't have in second sentence, in third sentence we don't have hello, in fourth sentence we don't have hello. So we only have hello in one sentence, so the df of hello will become 1. So now let's take a recap of TF and IDF. So TF is term frequency, which means how many times that how many times the word is occurring in a sentence, in a sentence or document. IDF means, IDF means we have to calculate log of n upon dfx. So this n means number of document or sentences in data. And this dfx means if we are calculating it for hello, so how many sentences, in how many sentences this word is occurring, in how many sentences this word is there. So in how many sentences word is there. So this was the formula of TF-IDF. So in total we just say TF into IDF. So for every word we will calculate this, and this will give the vector representation of text. So this is basically used in text classification tasks, because it tells the term frequency, the mostly used terms, or in the sentence, the most frequently used terms in the sentence, in the document, in the data. So we generally used it for text classification tasks, and like recommendation systems and spam detection. TF-IDF is used in these tasks. So now let's see how to implement TF-IDF in Python. So we have to import it, import the library. So from sklearn, from sklearn dot feature extraction. So we are extracting feature here, that's why it is in feature extraction class. So feature extraction dot text put TF-IDF vectorizer. Now let's create our data. So data will be equal to our first sentence is same hello world, and our second sentence is beautiful. Third sentence is world is mine, and fourth is world. Let's take any. So let's take water is wet. So we have four sentences in our data, and now let's create a class, create an object of this TF-IDF vectorizer class. So we have created the class of TF-IDF vectorizer, and we have dot fit transform, fit transform, fit transform, fit transform method in this TF object. So we will pass our data directly here. So we will pass our data, and we will store all the vectors in vec variable data. Now let's see all the vector. It is giving some error, TF-IDF dot fit transform, and we are passing our data here. We have to convert this into array. So we will convert this to array, because sparse matrix of type class numpy with L1 stored element are compressed sparse row format. So we have to ultimately convert it into array format. So now we have this vector representation of these sentences. So if you want to check for the first sentence, so for first sentence we have this vector representation. So this is how you implement text vectorization, or TF-IDF vectorizer in Python. Now let's discuss the pros and cons of TF-IDF. So if you will see here, so let's first discuss why we are using log here, log in IDF. So TF is term frequency and IDF is inverse document frequency. But we are in term frequency, we are just simply writing n by n. But in this, we are using log e. So we are using log e because this number of documents can be vary in the data. So this IDF ultimately depends on the number of sentences in the document. So let's say we have 10,000 sentences in our document. So our numerator will become 10,000, and ultimately this value will become very high. And if we will not introduce this log here, so this value will become very high. So now ultimately we have to multiply it with turn frequency. So the turn frequency is low because it is only depending on one sentence. It is only depending on one sentence, but the inverse document frequency is depending on full document number of documents, which means in 10,000 documents. So this value will become too high. So this IDF will dominate over the turn frequency. So to normalize that, to normalize the value of inverse document frequency, we introduce a log here to minimize this value, and reduce the contribution of inverse document frequency in the turn frequency. So this is the full mathematical intuition of turn frequency and inverse document frequency. So now let's discuss the pros and cons. So pros are very good here because we are getting the most frequently used terms in the data. So we can easily, if you want to do a classification task, you can apply this and you can easily find the most frequently used words in the data, and that will ultimately benefit your model. But the cons are here. This representation this representation is capturing the semantic meaning. So let's first see what were the goals that we have discussed. So the goals are, we have to capture the semantic meaning, we have to capture the context of sentence, and we have to maintain the sequence. So we are maintaining the sequence. Here, but are we capturing context of these words? Are we capturing the semantics of these words? So the answer is no. We are not capturing the context and semantics of these words. So that's these are the disadvantages of term frequency and inverse document frequency text representation. So this is the whole perspective of TF-IDF text representation technique. In this, we have seen how to calculate the term frequency and how to calculate the inverse document frequency, and what does these symbols, these numbers, and this formula represents. So now let's see the conclusion of the video, that what we have learned in this video. So we have seen what are vectors. What are vectors? Why are we converting text into numbers or vectors? And then we have seen most basic techniques of converting word into vectors, one-hot encoding, and also seen the practical implementation of this one-hot encoding with Python. And then we have seen the TF-IDF term frequency and inverse document frequency technique, and also implemented it using Python. So this was the video, guys, and but we are just getting started. In the next video, we will explore even more advanced techniques like word-to-vec, doof, and transformers. That's it for today's video, guys. If you found this video useful, don't forget to share, subscribe, and like. Drop a comment below if you have any questions or want me to cover other NLP topics. See you in the next video. Thanks for watching.